This video is going to be about electric potential energy, but at first we're going to start talking about gravitational potential energy because they're really sort of related to each other in the way that you view where and when you have high potential energy or low potential energy. So here we have two situations. We start with a rock that is high and it drops to be lower to the ground. In the second situation, we start with a rock that is low and we lift it up. Which situation happens naturally? Well, obviously, this first one happens naturally where if I have a high rock, it'll naturally fall. If I have a rock on the ground, it won't just naturally float into the air. Okay? As the rock falls, the potential energy decreases. We go from high potential energy to low potential energy. And if you remember the equation for gravitational potential energy, it is gravity times mass times height. Okay, so here gravity will affect it the same, mass will be the same, but the height will have changed in these two situations. And that is why it has high potential energy at the beginning and low at the bottom. Okay, when it is on the ground, it has very little potential energy. Opposite of that here, work has to be done to move it from low to high. Some energy has to be put into that situation to move it from low to high. So naturally, things want to go from high to low. Things do not naturally want to go from low to high. You have to put in work. Similarly, potential energy works the same way with electric potential energy. And electric potential energy is determined, for the most part, by two sort of quantities. The first quantity is going to be the electric charge. So two items with larger charges will have sort of stronger potential energy and electric fields associated with them, as well as the distance from the source or from whatever is creating the electric field or the distance between the charges, etc. Okay? And this sort of, if you think about this, this is very much similar to like the mass of our object in gravitational potential energy, and distance is very similar to the height of our object with gravitational potential energy. So we want to move our charged object. Here in all situations, we have a positive test charge. In this situation, we want to move it from A to B. And here we have a positive charge creating an electric field. And we talked in our electric field video that according to a positive test charge, positive charges create an electric field that goes away from that test charge. And so moving the positive charge here from A to B will ultimately increase it in potential energy based on its distance from the object. It does not want to be at B, therefore work has to be done to move it from A to B, and that work is then stored in the object as potential energy. And so here, having a smaller distance when the objects don't want to be together will ultimately increase it in potential energy. On the other hand here, we have that same positive charge creating the same electric field away from that charge, but here our item starts at B and wants to move to A. When it moves to A, it is now moving in the direction it wants to go, and therefore will decrease in potential energy. No work has to be done. It will naturally occur if it is allowed to, and therefore it'll decrease in its electrical potential energy because it is moving more where it wants to go. It is putting more distance between itself and the other positive charge. Here we have sort of a similar situation, but with a negative electric field where a positive test charge will want to go towards the charge creating the electric field. So here we have our positive charge. It wants to move from A to B, and no work has to be done to move it from A to B. It will naturally go there because it is attracted to that negative charge creating that electric field. Therefore, we will decrease in potential energy because it is moving where it wants to go. On the other hand, we have this negative electric field where the electric field is pointing towards the negative item. We have a charge at B that wants to move to A. It does not want to go that way. It wants to go towards the negative item. And so because we're moving it in the opposite direction of where it wants to go, it will ultimately require work to move there and therefore increase in potential energy.